Hey, welcome to the second day of Kotlin online event. My name is Yegor Tolstoy. I am the head of product management in Kotlin. I hope that we already met yesterday on my talk contributing to Kotlin. Please say yes. I'm going to rival Kate in the number of views, so I hope to get you on my side.
Hey, my name is Kate and I'm a developer advocate for Kotlin. I've joined Kotlin team this year and I'm so excited to be here with our incredible speakers, with Igor, you of course, and with this amazing Kotlin community. And frankly speaking, Igor, I'm not sure that it's a good idea to rival in the number of views, because tomorrow I'm going to speak about KMM. And if I try to count the number of comments about KMM in the yesterday's stream chat, well, I strongly believe in my victory.
We'll see, we'll see. Well, you know that Kotlin is much more than just the language syntax and the compiler. One of the key elements of the Kotlin ecosystem is its core libraries. And today we are going to see what's new in this area.
Cool. But before we start enjoying talks, let me remind you what ways our listeners have here to interact besides classics talk watching. Yesterday, while I was watching the event, I caught myself a few times that my focus, was jumping from the talk to the chat, because you all were so active. There were a lot of interesting discussions and funny stuff. So I really felt this wild and crazy and cool vibe. And my suggestion is, please don't stop. Please use the chat right next to the stream, ask your questions and just share your thoughts and what you feel about all that's happening. You can also ask your questions on Twitter using hashtag Kotlin14ask. And after each talk, we will have short conversation with a few questions from the audience. And at the end of the day, we'll have a larger discussion panel with all the speakers of the day. And there we will try to go through as many questions as possible. And one more thing about questions, you can even win a small prize. So start submitting your questions right now. And by the way, we already have 3 winners for their questions from yesterday. And Igor, please, can you share them with us?
Okay, no problem. So the first one, I love this one especially. Since the roadmap for Kotlin is public now, can someone contribute externally to one of your upcoming features in the plan? What is the process for this? So that's the first winning question. The second one, in what way you want users to contribute the most? I also like this one very much. I think that you can think that I was the one
that was
who
your
chose.
question. Yeah.
Okay, and the last one is, don't you think making public the default visibility modifier was a mistake? Shouldn't the default visibility be internal?
Well, great questions, and congratulations for our winners. You all get a brand Kotlin cool mug. So please contact us by writing an email to kotlin14org.jetbrains.com, and you can find this email in our chat. So I think you won't miss it.
Yeah, and there is another way to win some cool stuff that is called Quiz Quest. We will have a quiz for each of the talks that follow throughout the whole event. Detailed rules are under the stream, so make sure to register with the same email address that you used for previous quizzes. And on the 26th of October, we will have actual raffle that will be based on the best answers.
Let's go to the talk, maybe?
Yeah, and while you're preparing to participate in the quiz and so on, let me introduce you to the following talk. Well, everyone loves coroutines. So Tolstopyatov, team lead in Kotlin libraries team, will tell us about all the new things in the coroutines library and tooling and share some light on their future plans. And he really knows what he's talking about, because he had a huge experience working with highly loaded distributed systems, JVM internals, and concurrency. And now, enjoy the talk.
Hello and welcome everyone. My name is Seva, and today I will be talking about coroutines. I'll tell you what has been changed in coroutines since the last major update, how the programming model with coroutines has been changed, and what to expect in the future versions of Kotlinx coroutines. But first, let's talk about debugging. Coroutines debugging was one of our known major and long-standing pain points known to any developer who tried to debug an application with coroutines in it. And this experience, it was far from perfect. Stack traces were incomplete, local variables were missing, and suspended coroutines were almost impossible to find. Well, I'm happy to tell you that it has been changed. But first, let's take a look at this example. It's a simple function, it has a busy loop in it, it receives elements from a channel, processes them, nothing too fancy. Suppose you have a bug somewhere here. What are you going to do about it? Well, probably you'll write some kind of unit test or sample application, you'll put a breakpoint, you'll start it, you'll wait for breakpoint to hit, and you'll start examining your program state. What shall you see in the debugger? Previously, you would see something like this. A latest stack frame, with which is our process user events, its local variables, its arguments, and that's it. You won't be able to see, let's say, who called this function, or what local variables or arguments call ahead. And it's not because the stack trace is broken. No, it's a real stack trace. And it is because how coroutines are implemented internally. But still, it's not what you want to see, because it's not that useful. But if you have a recent enough IntelliJ version, which is 2020.1, you'll see a completely different picture. You'll see a proper stack trace here. But what has been changed? Your program, it stays the same. Execution of your program, Kotlin compiler versions, and so on, they all remain the same. It's actually IDEA who became smarter. Now it's able to detect that the current thread is executing a coroutine, it recovers its stack trace, and it draws it here. The stack trace, it isn't real. For example, a tool like JStack, it won't show you here. It won't show you it. But still, it's what you want to see. And even though this stack trace isn't real, it behaves like a real one. You can, let's say, examine stack frames, you can see its local variables, its arguments, you can execute statements over them, you can put watches, you can change them. Basically, you can do anything you would like to do with a regular debugging. Even better, if you have a recent enough Kotlinx coroutines version in the class path, you'll see an additional coroutine stub window, which is pretty similar to threads window, thread stub in regular IntelliJ debugging. This stub, it shows you all the coroutines your application has, including running coroutines, suspended coroutines, and even created but not yet started. And like with threads, you can observe them, you can see where they blocked, suspended, running, what are the local variables, and so on. Even better, if you got lost and have no idea where some particular coroutine came from, you can see a coroutine creation stack trace here, which will help you to detect where this particular coroutine came from. Finally, IntelliJ and debugger have first-class support of coroutines. And with these changes, we expect coroutines debugging be as simple and as pleasant as regular debugging. So have a nice debugging, but enough of it. Let's talk about flow. But before telling you what has been changed in the flow, let me remind what flow is. Basically, flow is a sequence. And like all the Kotlin sequences, it can be built, it can be transformed, and can be mapped, filtered, or consumed. Or in flow terms, they can be collected. But what's the main difference between Kotlin sequences and flows? And this difference is suspension. In flow, you can suspend everywhere. You can suspend in builder function, you can suspend in maps, transforms, filters, you can even suspend in terminal operators. And this suspension, it actually behaves like a back pressure management, but you don't have to do anything about it. Compiler will handle it by itself. Shortly speaking, flow is as simple as Kotlin sequences, but it also has all the benefits of reactive programming, where you don't have to manage back pressure. Our recent addition to flow is state flow. But before telling you what state flow is, let's talk a bit about the problem domain. What state is, what problems can be modeled with state, and how to manage it. According to Oxford Dictionary, state is a condition or way of being that exists at a particular point of time. A good enough example of state is a plain old variable. And this variable, it has a lot of values during its lifetime, but at any particular point of time, it has one, and you're interested only in its latest value. A bit more complex example will be a downloading state. It has a straightforward state transition from not initialized to started to being at some point of progress, and finally a successful download or failed one. And you're not interested in any intermediate results here as well. If you have completed download, you're not interested in receiving events of being at each particular point of progress. You're interested in whether this download is completed or not. So how can we manage it? And how can we manage it in a reactive and responsive manner, ideally as a flow? Previously, we would recommend to use conflated broadcast channel. But conflated broadcast channel is a channel, and channels are complicated beasts. They, let's say, have a determined life cycle and a lot of API, and thus they're a bit slow. It's not like all channels are slow, no. But this particular problem, state management, can be solved in a much more elegant and concise manner. Even more, channels have a lot of API. For example, they can be closed, or they can be canceled. And it's not really a good fit for state management because you cannot close a variable. You cannot cancel the state. So instead, we decided to deprecate conflated broadcast channel and introduce our own new solution, state flow. State flow is just a flow with a value, with its state. And with the best traditions of Kotlin standard library, it comes in two flavors, read-only state flow and mutable state flow, which has its state mutable. So you are free to decide what to expose to your clients and what to use internally in your implementation. And any update to this value, to its state, will be reflected in all flow collectors by emitting a value with state update. So how can we manage our downloading state with state flow? Let's take a look at the example. First, we have to initialize the flow. And for that, we have a mutable state flow factory. And take a note here. We create and use a mutable state flow internally, but for our clients, we expose a read-only flow, so they won't be able to mutate it. And we have a downloading function. In it, we initialize the state with initial value, we create a connection, and start our heavy lifting. When new data arrive, we start processing it, and we update our state with a progress, or with some kind of percent. And eventually, we'll update it with its final value, successful download. And that's it. We don't have any channels here. We don't have any coroutines here, or any brand new concept to learn. It's just as simple as that. You have a plain old variable as the implementation detail, and for your clients, you expose a simple and familiar flow. But what if, instead of managing a state, you want to manage a series of state updates, or generally speaking, an event stream? For that, we have a shared flow. But again, let's talk about problem first, about its domain, what's a real-world example, and only then let's discuss a solution. A good example of event stream will be a CO2 detector device. And CO2 detector device is a source of events, and its measurements, a level of CO2 in your apartment, is events. And here, you're not interested in each particular event. You're interested in a few latest ones. For example, to calculate a windowed average or smooth down the spikes. And this is a hardware device. It's real. You have to connect to it. And this connection is typically costly, so you don't want to duplicate it for each listener. You want to share it. Let's further discuss general constraints of event processing systems. First of all, it's a costly connection. Even connecting to a simple device as CO2 detector may take up to a few seconds, so you don't want to pay this price each time you want to receive some data from it. So you want to share this connection. Secondly, it's laziness. User may want to close the page before the source had a chance to initialize, or the whole coroutine scope can be canceled. And you don't want to create the connection when it's not really necessary. So it should be lazy. Or in third terms, it should be cold. Thirdly, clients are typically interested in a few latest values, and they're not ready to wait for new ones because they may not arrive soon, or they may never arrive because, let's say, a device got stuck somewhere in a hardware problem. And take a note here, this is not something channels are capable of, so we cannot model and solve this problem with channels, at least easily. Finally, a significant degree of flexibility is required to manage the source of events, because it is a connection, it is a resource, so you want to close it, but when to close it? Some clients may want to close it as soon as there is no listeners, others may want to wait for a few seconds to avoid paying reinitialization costs if new clients will arrive soon. And in some application domains, replay log should be reset as soon as the connection is closed. And in other application, it's okay to leave reset replay log as is. And it's a tricky problem. It's not that easy to solve. And what should be a default is also not clear. Let's see at existing solutions. And Project Reactor and Eric's Java team did a great job here, and they introduced such concepts as subjects, processors, connectable throwables, and domain-specific operators such as share, replay, ref count, connect, auto-connect, and so on to solve this particular problem. And this is actually a great place to start if you want to implement your own solution. But we cannot simply duplicate it or slightly adjust and adapt to Kotlin, because this API is Java-centric. It knows nothing about coroutines, about flows, about cancellations, and instead of suspensions, they have to manage a back pressure. But still, we carefully studied these implementations, their use cases, their trade-offs, and eventually ended up with our own solution. Welcome everyone, shared flow. Shared flow is just a flow that has a replay cache that can be read as an atomic snapshot. But again, as with stateflow and as with Kotlin standard library, it comes into flavors: regular shared flow and mutable shared flow, which is a little bit more trickier. Mutable shared flow can be used to emit values from both suspending and non-suspending contexts. Its replay cache can be reset, and it also exposes its collector's count as flow. Why is it necessary, you may ask? It's for the sake of flexibility. For example, you can start collecting this flow and wait for subscription count to become 0, then wait for a few seconds, and only then terminate a source. Or you can do something completely different. It's up to you to decide. But this interface, implementing this interface is a tricky problem. So we're introducing a few convenience methods to work with shared flow. And like with stateflow, we have a mutable shared flow factory to create a fresh instance of shared flow. And it can be completely customized. You can specify its replay log size, its buffer capacity, and what to do if buffer is full. For example, you can suspend, you can conflate values, you can throw an exception, or you can terminate the source. Whatever suits you. But what if you already have a flow and you want to share it, and you are not ready to rewrite your code for some kind of callback-based API with a fresh instance of mutable shared flow? For that, we have a sharing operator, which also can be customized. I'm not going to give you an example of how to use shared flow to solve a real-world problem here, to keep this talk short, but we have plenty of them in our documentation and coroutine guide, so please go and check it out. Apart from major updates, we also have a few small, but nevertheless important changes in flow, starting with core operators. Core operators are building blocks that can be used to express an arbitrary transformation over the flow. In fact, initially, we've carefully studied your feedback, your feature requests, your demands on various flow transformations, and was thinking what to do about it. Your use cases were perfectly valid. But if we were going to implement all of the proposed transformations, we would end up with like 100 flow operators. And it's not what we want to. 100 flow operators is hard to name, hard to learn, hard to maintain, hard to keep consistent and aligned with each other. So instead, we've decided to extract a set of low-level building blocks that you can easily combine to express a transformation you need. Then we introduced, and what's more important, enforced flow invariants, such as context preservation and exception transparency. And these invariants are crucial to keep implementation of flow operators safe and sound, and not able to interfere with other flow operators. It may sound a little bit vague, so let's jump right to the example and see how it works. Consider this terminal operator. It's pretty simple. It prints each element of the flow. Then, if an element is equal to 42, it throws an exception. Let's apply it to some flow, but not an arbitrary flow, but to a tricky one, this one. This flow emits a 42, then it catches an exception and emits 21. What are we going to expect here? First, please note that this flow implementation is actually incorrect. It violates exception transparency because the downstream, it signaled us that it has no longer interested in further values, but still we are trying to emit 21. Yeah, you may think it's kind of corner case and it's hard to write it manually, but no, it still is possible. It's still possible to do so by mistake or because of some weird interaction of maybe helper functions. And it actually can break existing operators, such as first of null, and so on. And that's not what you want. If you're using flow in the initial release, 42 and 21 were printed to the console. And it's not that great. But in a newer kotlinx-coroutines, you'll get an exception. And this exception will be particularly detailed. It will tell you what went wrong, where it went wrong, why is it forbidden, and what's more important, how to fix it. And here it suggests us to use a catch operator. So let's apply this suggestion and see what happens. At the end, we'll have this. A simple, concise flow of single element with a declarative catch operator that handles an exception and a terminal operator. And that's it. Let's move on to the general coroutines updates, and starting with Android-specific ones. And here we have lovely additions for Android ecosystem, starting with optimized deck size of coroutines. And when I'm saying deck size of coroutines, I actually mean a deck size of application with Kotlinx coroutines. To be more precise on how did we measure it, how we measured it, we actually wrote a simple application with a few activities in it, and we used coroutines here and there, flows, channels, coroutine scopes, and regular coroutines, launchers, and asyncs. Then we built this application with array and minifier enabled. And so how much size Kotlinx coroutines package takes. We carefully studied our bytecode contributors, number of class file sizes, and trimmed down some debug metadata that is not necessary for Kotlinx coroutines to operate. And as a result, we've been able to achieve a major 30% improvement. As a side effect, startup time of application with Kotlinx coroutines was significantly reduced. Most of the gains here came from the reduced number of class files, but also we've completely rewritten our service loader to be more array and disk friendly. So you can finally forget about any Kotlinx coroutines related stalls on your application startup. Last but not least, we've completely rewritten our coroutine scheduler that is used in dispatchers.default and dispatchers.io. As a result, we've been able to reduce the CPU consumption in various use cases by up to a factor of 4. If you're interested in how is it possible, please follow this link to pull request, which has internal documentation of coroutine scheduler. And here you can see all the implementation details, consider trade-offs, and benchmarks we were measuring. Let's move on to Java-specific updates. And let's start with run-interruptible function. Run-interruptible function is a bridge between a blocking interruptible Java world and non-blocking and cancelable Kotlin world. And it actually transforms any cancellations into thread interruptions and any thread interruptions into cancellations. But what's more important, it does so even for outer cancellations. For example, if this timeout coroutine was cancelled, or if the whole outer scope or your activity was cancelled, then it interrupts the current thread. Blocking QTake or any other blocking operation will throw an interruption exception, and this function will transform it to cancellation exception. So you can finally forget about your coroutines getting stuck in blocking Java calls as long as you are wrapping it in run-interruptible function. Apart from that, We also have an integration with blockhound that helps you to detect blocking calls where they shouldn't have been performed in the first place, for example, in dispatches.default. And for advanced users and library authors, we also provide an integration layer with Java util concurrent flow from Java 9. That's it with coroutines updates. But it would be unfair to leave you here without shedding some light on what to expect from the future versions of Kotlin coroutines. Our first priority is to stabilize shared flow and state flow. So please try it, use it, break it, and tell us about your experience, whether it's positive or not. And we're keen on evolving this API based on your feedback. Our second problem is resource management. If you have a resource that is closable and that you want to send over a channel that may be canceled both from receiving and sending side, and you want to close it exactly once, how to solve it? Currently, it's a tricky problem, but luckily we know how to fix it, and we are going to introduce a new API in 1.4 for this particular problem. We also heard your feedback regarding offer and pull methods on channels, and these methods, they're pretty useful to integrate with a third-party callback API, but they have major gotcha. They may, even though they claim to return Boolean or nullable type if false and null respectively if the channel is closed, they still can throw an exception, and it's easy to miss, even during a code review. So we're going to deprecate them and introduce a new methods on channel that have exception type reflected in method return types, leveraging inline classes and sealed classes. Flow API also have some room for improvement. And here we're going to provide a set of time-specific operators for UI programming, such as debounce, sample, throttle, and so on. Coroutine testing is not as pleasant experience as we would like to see it. So we're going to fix all the bugs, stabilize it, and maybe even make it a multi-platform dependency, so you can use it from common code, though it's still an open question. Finally, we're going to introduce a sliceable dispatchers. So we can take an existing dispatcher, let's say a dispatcher.default or an arbitrary thread executor, and you can make a slice to limit a concurrency of your application. But this slice, it will be piggybacking on existing threads. It won't create any new threads. So it will save you a number of threads and your application footprint and eventually battery life. That's it with coroutines. So thank you for your attention and have a nice Kotlin. So when do we stop? So I will stop typing because I heard it's too irritating.
Hey Seva, thanks for a wonderful talk. As we know, it's hard to learn coroutines in 30 minutes, so let's try to do it even faster and spend the next 10 minutes answering our audience questions.
And so let's only 10 minutes and a lot of stuff to discuss. So the first question is, with flow gradually stabilizing, this provides the opportunity to add more complex features to the standard library. Will we see things like a generic server or generic state machine in the future of stdlib, similar to languages like Erlang or Haskell, or would this be something that is better owned by third-party libraries?
Okay, thanks for the question. Actually, we are trying to keep standard library small and concise. So this primitive state machine, for example, it's quite heavyweight, so it will be a better fit to a third-party library. So with standard library, we try to keep it simple.
Okay, it's pretty clear.
Okay, and the next question is from Jamie. Are we ever going to get suspendable properties? A suspendable lazy val would be really helpful.
Well, it's a tough question because it's on the edge with coroutines and language design. And if you heard Roman talk, we have plenty of issues in language design, which we're keen to solving. And suspendable lazy vals, it's not the case because they have a lot of problems in the implementation, they have a lot of design, and the pull properties are typically used for something lightweight, idempotent, and they do not throw. And suspendable lazy vals is the opposite of that. So it's unlikely to see it in the nearest future, but maybe somewhere around Kotlin 1.6, we'll revisit it again.
I think it's a good place to remind you that if you have some use case in which you can show us why you really need suspendable property, then post it in uTrack so that our language design team can rely onto it.
Yeah, it would be great.
The next question, I have 3 words for you. Coroutines, Kotlin native, and multi-threading. Yeah, expected one.
Yeah,
so
it's a painful one.
Yeah, painful and expected, and of course we want to discuss it now as we're all here. So what's the current situation with multi-threading coroutines on Kotlin native? Well, we all know we have a separate branch, but will it be always separated, or so what's the plans about it?
Yeah, it's complicated. So as you may have heard, we actually have a lot of plans regarding Kotlin native and its memory module. And in a year or so, we'll completely rewrite it, and the coroutines will be working on Kotlin native as easy as simple as regular JVM coroutines. But it's not the case right now. And for that, we have a separate branch, native multi-threading, where we have most of the coroutines code rewritten to comply Kotlin native current memory module. But it's not something we would like to maintain in the long term. So it now has its own code base and its own release cadence. We are going to merge release cadences. So regular Kotlin coroutines will contain native MTR changes in its native counterpart, but we are not going to merge them in the main line. And in a year or so, when a new memory model will be is developed, we're going to completely get rid of it and just release coroutines as is, and they're expected to work.
Mm-hmm. But for now, am I understand correctly, so it's absolutely okay to use this branch before this whole stuff about new memory model Kotlin native will be released?
Yeah, sure. We just have some restrictions and limitations regarding Kotlin native, but in general, it's okay. People live with that, and they're more or less glad with that.
And how from the user perspective will look the usage of the native MTR? Well, what will be written in the Gradle file?
Well, they just have to patch a dependency on kotlinx coroutines and replace a regular version with version prefix native MT.
Mm-hmm. Mm-hmm. And can we expect for them smooth migration to the main branch after MTR version will be stopped to support?
Yes, they will just have to use a regular version, and that's it.
Mm-hmm.
Okay, so the next question. Stateflow looks like it's a complex thing, so the question is stateflow like a behavior subject from RxJava?
Yeah, it's pretty similar, but flow specific. Exactly. It's a pretty short one.
And one more philosophical question. Do you see flows replacing libraries like RxJava, or do they have their own uses, apart from maintaining legacy code, of course?
They obviously have their own uses, and it's actually a great framework that made a great start for Kotlinx coroutines and Flow in particular. So, for example, if you have a lot of interop with Java-specific frameworks, such as RxNative, for example, Vertex maybe, or JavaFX, it still has a good use. So, but for Kotlin-only projects, it's preferable to use Flow. But okay, again, it's up to you. It's not like one is better than the other.
Okay. There was one comment in YouTube chat that people really love coroutines, but they don't love debugging of coroutines. So the question is, does new coroutine debugging, will it work during debugging coroutines in iOS project using KMM?
Unfortunately, not yet. We are obviously going to fix it, but not now because we have plenty of other issues in KMM development.
Mm-hmm.
Mm-hmm.
But yeah, it's hard to imagine a complete and stable project such as KMM without debugging support in this area.
So just waiting and have our finger crossed. I love the next one. Shared flow is blowing my mind. This is solving a specific issue at my place at work. Is this experimental?
Yeah, it's experimental for a while, and it will be stable in 1.4 in the end of October. So pretty soon.
So do you suggest to already start using experimental version or to wait for a more stable one?
It depends on your use cases and on your project. So for example, if you're working in bank, please wait for stable versions. But if you're keen on using new features, provide us feedback, or maybe to just tell us about your experience. Yeah, go ahead. We'll be happy to hear it.
Okay, and one more question about the availability of Coroutines debugger. Will it be available on Android?
It's better to ask Google folks. But I've heard they're working on it, so I didn't say that.
Okay. That's great.
And I think the last one for our current Q&A session, and of course I want to remind you that after all the talks we will have the big Q&A sessions where we can continue to discussing coroutines, debugger, and all our loved stuff. So the last one, how coroutines are going to change when Project Loom is ready on Java?
A tough question. Basically, we'll provide an interop layer with Loom and with its fibers, but it's far from complete right now, and it's hard to predict what it's going to look like. So it's hard to tell what exactly are we going to do. And such projects, such as Project Loom, as Valhalla, they take years to develop. For example, Valhalla is developed for almost 10 years, I suppose, and Loom is developed for 3 years. And I think it's at least 2 more to wait. So it's hard to tell really.
Okay. Thank you very much, Seva, for your talk and for this interesting discussion, and see you at our last Q&A session part.
Okay, thank you for inviting.
Thanks, that was brilliant.
Have a nice day.
Okay, and Kate, we're the only ones here once again, so let's talk a bit about radio shows. What is the last time when you listened to some radio show? You know, that type of shows when a bearded host asks you a funny question and asks to respond with SMS that costs $10 or more.
I'm not really sure because, you know, I'm a digital nomad, as all developer advocates, of course, and I live without any car. But today I want to have such an opportunity, such a show right now on Kotlin Online event. Because why? Because we can. So folks, in our chat, prepare to interact with us a lot. Please. We'll ask you some questions, maybe strange, maybe funny, and of course they all will be interesting, and read out loud your answers. And to warm up, let's start with a simple question. So, if Kotlin will be an animal, which one it will be?
Wow.
Yeah.
That's a good one.
I'll give you time to think, and while you're thinking, I want to introduce you the next talk. Igor, I know you was a pretty successful mobile developer in the past, and you even invented your own mobile architecture. So, the question for you, as an experienced mobile developer, what was your favorite kind of tasks? Besides the, of course, after painting views and drawing buttons and all of that stuff.
Well, waiting for Xcode build, creating your own DI frameworks. Oh, I know, parsing JSONs.
Yeah. Then you definitely will enjoy our next talk from Leonid Startsev. He worked at Kotlin libraries team for more than 2 years. He loves sharing his experience with others, and he is passionate about writing code that will give people new possibilities. For example, parsing JSON. So today, Leonid will tell us about kotlinx-serialization 1.0, first public stable release. And let's enjoy the talk.
Hello everyone, my name is Leonid, I'm working in Kotlin libraries team, and today I want to talk with you about kotlinx-serialization 1.0, our first public stable release of this library, and what it's all about. Well, kotlinx-serialization is a Kotlin multi-platform, multi-format, reflectionless serialization framework. And things we are going to cover today is an introduction to Kotlinx serialization for those of you who are unaware of this library and never used it. Then we'll go over serialization APIs, what you can use and in this library, and how you can benefit from it. And we are, of course, going to cover some new features in 1.0 that I want to present you. Then we'll discuss future plans for further development of this library, and we'll cover a setup for new users and a migration path for our old users that used previous pre-1.0 versions. So let's start with a brief introduction of what Kotlinx serialization is. So you may ask, why do we need yet another JSON parser for Kotlin if we already have libraries like Jackson, Moshi, JSON, and so on? Well, the answer is pretty simple. All these libraries are Java libraries. So they may not work well with Kotlin in some certain ways, and I'll show you an example of it. But first of all, the Kotlinx serialization is, of course, a multi-platform library. And it supports all Kotlin flavors, Kotlin JVM, Kotlin JS, and Kotlin native. So you can use your serializable model in common code on your Android application, on iOS, and in your backend server, and whenever you like. So this is one of the important features, but not all of them. So why it's called Kotlin-oriented library? Let's start with a simple example. We have a data class project that has a name, which is string, and a language property, which is also a string, and has a default value Kotlin. So, and we try to parse such a JSON that have a name property, but doesn't have a language. So if we try to parse such a string with a JSON, we'll find out that it doesn't know anything about Kotlin default values. So the language here would be null, which is obviously very bad for us because it breaks a type system. We get a null in the non-nullable property. We got runtime crashes, we got bugs all over the place, and it's hard to catch them. So of course, if we try to parse such class with a Kotlinx serialization, it knows everything about Kotlin default values, and it correctly inserts a default value from the class constructor. Another major point and difference of Kotlinx serialization from other libraries is it being explicit. So every serializable class has corresponding serializable annotation. And if we try to and if we forgot such an annotation, for example, here we try to add to the project a new class, data class user, which is not serializable. So we try to add the property. And the compiler tells us that serializer for type user has not been found. So this class cannot be serializable anymore. And what's important here is that this is a compile time check. So it saves your build time, it saves your time to find bugs, that this code simply wouldn't compile, and saves, and it helps. So, but of course, explicitness doesn't mean verbose. As you know, Kotlin is explicit and concise language, so Kotlinx serialization 2. Let's break down another example with JSON, where we try to parse a list of projects. So if we simply put a list class Java here, we surprisingly find out that actually this is not a project class. This is a linked tree map from a JSON. And that happens because, of course, as you know, the JVM erases generic arguments. So JSON doesn't know that this is a list of projects. It only knows that this is a list of something. And it tries to save you by putting all the properties in the map. But we, of course, again get runtime errors, crashes, and so on. You may already know that to solve this problem, you need to provide a JSON with a type token. So we create an anonymous object here, providing a type token, and it correctly captures all the generic arguments, and we get our project at last. But this code looks quite cumbersome. It is hard to understand without deep understanding of the problem, and it looks ugly. So, well, if we compare it to kotlinx-serialization, kotlinx-serialization knows about generics something, and it correctly parses our project class without additional construction. So we just decode from string, list of projects, and it simply works. Let's take a closer look at this magic. So in Kotlin 1.4, we have a new type of function that is inline, reified, and returns ktype. Ktype works mostly like a type token, so it captures generic information. If we ask for type of some complex generic type, like a box of lists of string data, and print it, we get all the generic arguments. But what's important here is that this type of function is a compiler intrinsic, so it doesn't create you an anonymous object. It almost doesn't have any runtime footprint. And it works again in all the multi-platform flavors, so on Kotlin JVM, Kotlin JS, and Kotlin Native. So of course we can use this function and write our own serializer function, which is provided in kotlinx-serialization, to create a serializers for box of lists and so on. So I will not cover today totally what k-serializer is. For us now, it's important that k-serializer is an entity that knows how to serialize and deserialize a particular class. So, and creating a serializer from a type token is equivalent to creating a serializer by your hand and using it in any of the decode function. So if you want to find out more about what k-serializer is and internal architecture of the kotlinx-serialization, you can come and watch my talk called Design of kotlinx-serialization from KotlinConf 2019. It's available on YouTube in the playlist with all the KotlinConf talks of that year. So what I want to also highlight is that Kotlin-serialization actually not only JSON library. It provides a lot of formats, and they all have similar APIs. We have also CBOR, protocol buffers, and some others formats, and even community formats that people contribute. So, and they all have a similar useful naming convention. So no matter what, if you want to convert your Kotlin class to a byte array or to a string or to whatever entity, all these functions called encode to something. So we have encode to byte array for protocol buffers, we have encode to string for JSON, and so on. And the inverse conversion is called decoding from something. So we have a decode from byte array and decode from string. And we try to make all the formats follow this naming convention. So no matter what format do you use, you will always know how to use this object and what functions to call. And another interesting design decision I want to present is the future-proof configuration of all these formats. Let's start again with the problem. In the pre-1.0 releases, we had a class called JSON configuration that has a lot of Boolean flags. And imagine we want to add some new cool JSON feature with a new flag. We can obviously add it, and it won't break any clients from the first look because, well, Kotlin has default arguments, so adding arguments, adding parameters to functions doesn't look like a big problem. But if we take a look to a binary dump, we'll find out that signature of the constructor has changed. So we do not have anymore an init function. With previous signature, we have an init function, new init function that accepts another number of arguments. And if you link with this library binary, you can get the Java lang no such method error. This problem was highlighted by Drake Wharton in his blog in a post called Public API Challenges in Kotlin. You can visit his blog and read this post to find out more about problems of binary compatibility of data classes. So we choose to solve it in the following way. So we do not have a JSON configuration now as a separate class. The JSON is configured by a DSL builder block. So instead of creating JSON from a JSON configuration with some parameters, you just simply open a DSL builder and put all the parameters there. So now if we add a new JSON flag, an ABI, it would result only in additional getters and setters in the builder class, and no other signatures would be changed. And it actually become even easier to configure JSON with such an approach. So in the previous releases, you had to create your JSON configuration, then create a JSON out of it. And if you want to tweak it, you had to call a copy method of the data class and create a new JSON out of it. So now you can simply create one JSON from another JSON object, and code becomes more compact and more readable. So that was a brief introduction to this library. If you want to find out more about features and supported structures, you can go to kotlinx-serialization GitHub and read our big guide for new users. Now I want to cover APIs in this release. So 1.0 release has several APIs that come in two different flavors. So we have a stable API that you can use and experimental API that we want to collect user feedback on and we want to evolve. So we need some design space to work on. So stable features we provide in this release are basically every feature you want from the default serialization JSON parsing library. You can serialize and deserialize classes from and to strings. All the annotations that control serialization process, like serializable, serial info, serial name, and so on, are also stable. We have polymorphic serialization that works natively for Kotlin sealed classes, for example, and for other Kotlin specific structures. We have some additional JSON APIs for manipulating JSON trees and so on. And you even can write some custom serializers if you want to tweak something. So to sum this all up, serialization, the serialization of serializable classes is stable and binary backwards compatible. And what's more important, that new compiler plugins will support all the library versions down to 1.0. So with this release, you can even use Kotlin 1.4.70 or higher, and so on. So you don't, if you don't want to migrate or update your library, you don't have to. But advanced usage patterns are still experimental, and these patterns are and these features are somewhat unique to Kotlinx serialization. So as you may know, you can write a custom serial format. For example, implement your own binary encoding or text encoding or something like that. You can do this with Kotlinx serialization, but this feature is still experimental because we are waiting on users' feedback for our classes to do that. And we also have a schema introspection, which can be viewed as a limited reflection capabilities for serializable classes. And all the binary formats I mentioned, like cbor, protobuf, and other methods or other formats than the JSON, they are also experimental because mainly they may lack some features or have bugs, but you can use all these experimental APIs and file as bugs. And we also have an experimental serialization API annotation that marks any API that is experimental and doesn't fall in all these categories. So to sum up, the API for writing format-agnostic serializers, schema introspection, and implementing custom serial formats could be changed in the future. That's why it's experimental. But if you accept this, you don't have to be afraid of this experimental API. You can use it. We will try to provide migration aids if this is possible. So you can migrate between releases without a lot of troubles. So we encourage you to try these APIs if you need them and provide us feedback. So, and also we have some internal functionality in the Kotlin serialization that's mainly located in the internal package or marked with internal serialization API annotation. This is the API that doesn't have any guarantees. It may be deleted in the next release or opt out or something. So you likely won't need it, but if you find out yourself that you are using it, then it's okay. But you should be aware that it may be broken in the next release. So you would better tell us about your use case in the GitHub issues so we can provide a proper public API instead. So, and let's move on to 1.0 new features. This section, I think, will be interesting for whole the auditory, both new and old users. And we have a lot of new features in 1.0. They are all presented in our changelog on GitHub. And here I want to highlight two of them that are most important, most interesting, and they also has been requested a lot of times. So the first of them is the more flexible deserialization of JSON. And it's expressed by chaos input values flag. So what this flag does. Let's return to our project example with the name and the language with default value Kotlin. And let's try to parse the following string. So here we have language property, but it has the value null. And the Kotlin serialization follows Kotlin type system. And it means that you can't parse null value to a non-nullable type. So usually the deserializer here would throw you an exception with the message that you can't put a null to a non-nullable type. But with the chaos input values flag, you can treat the null values as missing values. So you get your default Kotlin value right in the object. It may be convenient when you are interacting with the APIs that sometimes return null, sometimes omit the property, and sometimes do something else. So it allows for more flexible deserialization, as the title says. So let's take a look at another important feature, like a polymorphic deserialization. As I said, the kotlinx-serialization supports polymorphism in Kotlin sealed classes and abstract classes natively. For sealed classes, you do not need to create any additional configuration. So let's try to convert our project class to a sealed class hierarchy. So we add an owned project inheritor that has an owner of type string. And we add a start project inheritor that has a stars count. So let's try and see how these strings would be parsed. So usually when you have a polymorphic deserialization, you have some special property called class discriminator. In our case, it's type and says owned. And of course, we have this owner property. So, and you can pass this JSON to, of course, an owned project class. So, and if we have a start type with stars count, then we get a start project after parsing. It's a usual polymorphism that worked before and it works now, so useful feature, no surprises. But what if we have some unknown class discriminator, like a forked one? We do not know what forked is and what this number says to us. So in such case, usually a library throws you an exception with a message that polymorphic serializer wasn't found for class discriminator forked. But this may be not very convenient in cases that, again, you are interacting with third-party APIs you cannot control, or you have independent updates on your backend server and you are writing an Android application or iOS application. And it's not the best user experience when server got updated, user didn't update his application, and it crashed. So for that cases, we provide a flexible polymorphic deserialization. So to use it, you need to create a serializers module. We, again, won't cover what serializers module is here in details. For us, it is enough to know that serializers module is a thing where serializers got registered. So you register a specific serializer for a particular inheritor in the sealed or polymorphic hierarchy. So we say that under polymorphic hierarchy with a project class, we have now a default clause that accepts class name. Class name may be now in cases there was not discriminator at all, or you can take a look at it. It's just a regular string. You can decide what serializer to use depending on what string contents. Here we do not look at the string content. We simply return default project serializer, and we can write such a class default project that has only name and language in it. We don't get all this forked count or any other properties that were there, but we can at least display some meaningful information to our user, that is some project. So, as I said, we had more features. They are presented on our changelog and the guide. But now let's move to the future plans, because we, of course, wouldn't stop with the 1.0 release. We are going to develop this library further and improve it. So one of the most, again, features the people asked for is the I/O streaming. And we are going to provide a JVM-only API for Java I/O streams in the next release. Hopefully it will be 1.1 if everything goes smoothly. And the integration with kotlinx.io with multi-platform I/O streaming will be provided when kotlinx.io would be ready. So kotlinx.io doesn't have a public stable release yet, so unfortunately we can't depend on it. And for inline classes, another important feature, we remember about them. We have some work in progress on them, so stay tuned. And the last part of this talk, I want to tell you how to set up this library for our new users. So it's really simple. First, you have to apply a compiler plugin, because kotlinx-serialization uses a compiler plugin to work without the reflection. So it's just an additional line in your Kotlin DSL plugins block. So under the Kotlin JVM or Kotlin multi-platform plugin, whatever you use, you just include another plugin.serialization, and that's all. For GUI DSL, it's almost the same, just the ID of plugins are a bit longer. So, and the second step is to include runtime library as usual. Well, we publish it to Maven Central, but in case you want to try some dev builds or another intermediate releases, you can also include JCenter to your repositories. But all the 1.0 and all the stable releases are going to Maven Central. And you simply include it as regular implementation dependency. What's interesting here is that this artifact called kotlinx-serialization core is suitable for both JVM only and multi-platform projects. So if you have a JVM Android project, you can use kotlinx-serialization core. It contains a JVM artifact. And if you are using a multi-platform project, then you can simply include core in your common main dependencies, and all the platform dependencies will be included automatically to a project. So you don't need to write kotlinx-serialization core JVM, core JS, and so on. And for our experienced old users who have been with us for so long, I hope, we prepared a small migration guide. So if you update from, say, 0.20 to 1.0, you may notice that some decorations got deprecated. For example, a JSON stringify got this nice deprecation error that this message that using stringify is an error, and this method was renamed to encode to string. So, but you do not have to rename it manually. We used our standard Kotlin mechanism of deprecations. So if you hit Alt-Enter, you see that you have a replacement. You can replace this encode to string right away, or even replace it in the whole project. So when you hit the enter one more time, it replaces for you automatically. So, and for most of the deprecated declarations, we have such a replacement. So basically migrating would be just hitting the Alt-Enter. And in case you encounter some problems or unresolved references, it is possible that the entity you are looking for was just moved to another package. So you can include star imports for default package, built-ins, JSON, and modulus, and that would be all. It should work. So we also have a big migration guide, and as I said, changelog with all the renamings on our GitHub, so you can visit it and find out more information. So that was all for today with kotlinx-serialization. Thank you for joining this talk, and have a nice Kotlin.
Hey Leonid, thank you for your talk. Thanks a lot for your talk, and congratulations for the first public stable release.
Thank you. I hope you enjoyed it.
Of course, for sure. And now let's go through the questions, because I'm happy because we have a lot of them. So the first one from Hans Elegard: what if you need to use a third-party format binary which you can't change? Will you be able to write a new serialization backend for that format using the serialization library? And can we use... this is our question. I said we have a lot of them.
Yeah, okay. So the question is, can we write our own serialization format, basically? And yes, the Kotlinx serialization was built around that idea that we can have a lot of different formats. And as I said, this functionality is currently in experimental stage, but there are a lot of formats already written by our community, like an XML implementation, Avro implementation, and many others. So of course you can dig a little into our documentation and start implementing your own serial binary or text or whatever format you need.
Okay, thank you.
The next question. Can you install serialization in Ktor for content negotiation already?
Yes, Ktor has support for Kotlinx serialization, and the other question, as far as I remember, were about retrofit in the chat. So we also have a retrofit converter. We also have a Spring support. The recent Spring releases have the support of Kotlinx serialization merged in them. So you can use it with Spring, with other popular backend frameworks like HTTP4K and so on. They're all listed in 1.0 release blog post.
Okay. The interesting one is Kotlinx serialization using an internal APIs that are only available for Kotlin internal library developers, or are we able to make similar annotation processor?
Yeah, that's a tricky one, because there are a lot of gossips around Kotlin API, compiler API for plugins, and basically Kotlinx serialization uses this compiler plugin API. It's not public now, but of course we can't hide everything given that we are open source project. So there are already plenty of people that are experimenting with this compiler API. But what I have to say here is that it is not undocumented. It is undocumented and not very stable yet. But we have a compiler plugins on our radar. So in future we possibly may release a compiler plugin API for the public with proper support.
Sounds promising.
Okay, that's all is really promising, but let's talk about what really matters, the performance. did you make any benchmarks for Kotlinx serialization, maybe against Jackson or some other serialization libraries? So what do you have there?
You thought you catch me, but no, we of course measured performance. Well, even before 1.0 release, we measured performance and did some performance homework, measuring against Moshe and Jackson. And I can say that we are, by performance, on par with these frameworks. So we used some third-party benchmarks that other people wrote. But after 1.0, we release and write our own benchmarks and present them to the public as one of the goals for the next release 1.1. Because these benchmarks will allow us to enable another features that we first need to benchmark and then decide whether to, for example, set them as default ones or as additional ones.
Okay, thank you.
The next one. Can we use annotation serializable and parsable as both?
Yes, why not? This works pretty well. And these annotations are both examples of the compiler plugin API. So they can be combined.
Okay, and what are the plans to support JS export and serializable on the same class? People complain that it's not currently working.
Yeah, it's unfortunately pity that's just some compiler bug of the JS backend, and as far as I know, it is already being worked on, and I hope it will be fixed soon in 1.4.20.
That's good.
One about the plans. What about generic tree-like object serialization?
We do not have currently such plans for now because this is a complex feature that requires additional design, and well, we only have now JSON tree. But of course, we are welcoming any contributors that can provide this as a third-party format or something else. And so we probably can include this as a major feature in the future releases.
Okay, especially a good CTA in Hacktoberfest, during Hacktoberfest.
No one wrote that Kotlinx serialization is an amazing project, unfortunately.
But maybe it's an awesome project.
No.
So Igor, I want to give you an opportunity to ask the most important question, you know? About the
animal. Oh yeah, that's my special question. So Leonid, maybe you already have some hint on the background, but what if Kotlin was an animal, what animal would Kotlin be?
Well, I don't usually associate languages with animals, so no. I just say that my favorite animal is a tiger, so let Kotlin be a tiger, because Kotlin is powerful and nice looking.
Oh, you know that's
and it also have an orange. Yeah. And also have an orange stripes. So yeah.
Yeah. Good choice. So Leonid, thanks again. Thanks for talk. Thanks for this interesting discussion, and see you in our big Q&A part after all talks.
Yeah, of course. Thank you very much.
See ya.
See ya.
See ya.
Igor, we stopped at the animals, and maybe we can share some other crazy and funny and other ideas of our listeners.
Yeah, by the way, hey, our audience, we thank you very, very much for being so involved in our question. We laughed a lot with Kate with some answers, so thanks for it. And let me start. We will highlight a couple of answers, and I think that we will make a Twitter thread in our official Twitter account with all other answers, so subscribe to our Kotlin Twitter and wait for it. So the first one is Kotlin is a panda. Everybody loves it, it's cute, but have a strong power.
Oh yeah, true. The next one is quite original because which animal? A human. They swim, walk and fly. Not to mention they interop with basically the whole world. I love it.
That's my favorite part. Okay, Kotlin is a seagull because there are a lot of them on Kotlin Island, which is near with St. Petersburg.
Nice. I think Kotlin is like a Tony Owl because they are amazing at microevolution and are already adapting to climate change.
Oh, that's a good one. Cerberus, because Kotlin targets multiple languages, and Cerberus is a dog who has multiple heads.
I love this one, yeah. The answer or the question, I don't know. Kotlin would be a Python, maybe.
Maybe that was from Leonid.
Yeah, maybe.
Okay, and the last one, which we really liked and already posted to our team Slack, is that Kotlin is like honeybee, because Kotlin and its team always make useful things. Well, thank you.
So cute.
Yeah. Okay, Kate. So let's go further. You've joined the team quite recently. Tell me a bit about your developer advocate interview. How did you prepare for it?
Of course, I already had some hands-on experience with Kotlin, but of course I revamped my knowledge with some articles, videos and books, yeah.
Okay, and what is the best book about Kotlin programming?
Wait for it. I need to do a show. Of course, Kotlin in action, of course.
Wow.
I even have this exemplar, yeah.
And you are right. And here goes Svetlana Isakova, developer advocating Kotlin, who you may know from her numerous talks, articles, and of course Kotlin in Action book. Svetlana will present all the new things in Kotlin Standard Library. And now, let's enjoy the talk.
Hello everyone, my name is Svetlana Isakova. I'm a developer advocate for Kotlin. Today we are going to discuss new interesting features that were added to the Kotlin Standard Library. First, we'll talk about the new functionality that comes with 1.4. Then I'll illustrate how easy it is now to use the standard library in multi-platform projects. And finally, I'll mention a couple of new experimental things available for you to try. Let's start. I want to highlight several new operations and types, like the running fold and running reduce functions and the array class. But before that, I want to talk about the idea of making the standard library consistent and making it meet your expectations. The standard library comes with several naming conventions that you already expect to find there. It's quite convenient that you can rely on the naming convention when you're looking for a function. One of these conventions is the e or null suffix. The standard library contains two groups of functions, the regular ones and the corresponding functions, but with the or null suffix. The first group, the regular functions, return a non-nullable value and throw exceptions if something goes wrong. For instance, if a string can't be converted into an integer, or you try to retrieve a value from a collection but the collection is empty, or the required element isn't found in the collection. All these functions return a non-nullable result and throw an exception or error. These functions have on-null counterparts that return null if something goes wrong. We added a couple of new functions of on-null functions in Kotlin 1.4. The random on-null is new. It works exactly as you expect. It returns either random element or null if the collection is empty. It's really handy to have the consistent naming convention with two groups of functions. By the way, if you find something missing that you expect to be present, please file an issue in our tracker, share this information with us, and we'll try to address this. Next, I want to highlight a couple of important functions that didn't previously conform to the naming convention, the max and min functions. You probably noticed that both these functions were returning nullable values, and so you would have expected them to have the or null suffix, right? These min and max functions were introduced in Kotlin 1.0. They were there from the beginning, but now they are inconsistent with the whole library philosophy, so we decided to change that. You'll find in your code that in Kotlin 1.4, max and min functions are deprecated. IntelliJ IDEA and Azure Studio suggest replacing them with max or null and min or null functions respectively. These new functions are just synonyms. They behave exactly the same as the old ones. You can apply an automatic quick fix to replace all of the occurrences in your codebase. Currently, the old min and max functions are deprecated with a warning. At a later date, they will be deprecated with an error, so you won't be able to use them in your codebase at all. Sometime after that, the regular max and min will be returned to the standard library, but following the common convention, the new functions will return not null values and throw exceptions if the collection is empty. We want to provide a very gradual transition to the new functions. It's not a fast process. We don't want to change it all at once and break your code that already assumes they return null rather than throw exceptions. It will take several versions to get to the point where the library contains both max returning a non-nullable value and max or null returning a nullable value. The exact same applies to the max bar and min bar functions. We've deprecated them in favor of the new max bar or null and min bar or null. There is another improvement closely related to the max bar and min bar functionality. These two functions return the element in the collection that has a maximum or minimum characteristics, respectively. For example, if we want to know the maximum age among a collection of people, we had to do that in two stages. We first get the oldest person using max bar, and then get their age. But sometimes we only need the bare value, age, in our example. In Kotlin 1.4, we added new max of and min of functions to get that value directly. Max of returns the maximum value, whereas max by returns the element with the maximum value. These new functions follow the convention from the start. They were added together with their counterparts, max of or null and min of or null. Min of throws an exception and min of or null returns null if the collection is empty. Another convention that I want to talk about is the indexed suffix. That's also something that you already expect to be working for many library functions. All the functions for iterating over a collection and performing a given operation on it have counterparts, versions, that additionally take the index of an element for performing an operation. Kotlin 1.4 introduces their own each indexed and flat map indexed functions. In case you're looking at this and wondering what's the difference between for each and on each, here's a quick reminder. For each performs a given action on each element. It's a terminal operation. If you call it on a sequence, it forces the lazy computation to start and returns the result. On each performs the given action on each element, but also returns the collection itself afterwards. It's an intermediate operation. You can use on each and on each indexed in the middle of the call chain. If they're used on sequences, they don't force the computation to start. The curious among you might be wondering whether the library can mix these two conventions, or null and indexed. And the answer is yes. The new function reduce indexed to null that we added in Kotlin 1.4 is an illustration of that. Reduce analyzes the list and reduces its content to one element using the operation paused as a lambda argument. Reduce or null returns null if the list is empty. Reduce indexed or null complies with both conventions. The lambda argument takes an additional index parameter for reducing the list, and the result is null if the collection is empty. Next, I want to highlight two new functions that we added to the standard library. running reduce and running fold. These functions are very similar to reduce and fold, which were already present, with the difference that running reduce and running fold return each step of the operation in a list or sequence. Let's look at the diagram and see how it works step by step. In this example, we call reduce and running reduce on the range of numbers from 1 to 5. We are using a range here to demonstrate, but this could also be a list or a sequence. For sequences, each intermediate step will be computed in a lazy manner. First, we analyze the first element, number 1. Running reduce already returns as the first element in the resulting list. Then we analyze the second element and combine the first two elements according to the rule that is provided in the lambda. In this case, we sum up two numbers. Running reduce returns this sum as a new intermediate result. Reduce would return nothing at this point, since not all the elements have been analyzed yet. We continue. Running reduce returns intermediate values. Finally, when the collection is over, reduce returns the result. Running reduce returns you all the intermediate steps, with the final result as the last element in the list. That's the difference between reduce and its running counterpart. A similar function is added for fold functionality. Fold is different from reduce. It takes an initial value, while reduce starts analysis with the first element of the list. Running fold is also available by the name scan. The scan name is used in some languages, so it might be more familiar for some people. Scan here is just a synonym. It's another function in the library that only delegates to running fold. You can use whatever you prefer, similar to find and first to null. The difference between fold and running fold is the same as the difference between reduce and running reduce. Running fold returns all the intermediate results, while fold returns only the end result. Running fold, as well as fold, takes an initial value, and it's already the first result. Then it combines an initial value with the first element. That's the second result. As it continues, running fold reports an intermediate result after analyzing each part of the list. Running fold returns a list or sequence of all the intermediate values, while fold returns only the resulting value. The next topic that I want to cover is a new type, ArrayDec. It's now stable in Kotlin 1.4. It represents a double-ended queue and provides methods for convenient and fast access to the contents from both ends. ArrayDec in Kotlin is a part of the command library, so you can use it in the common code in multi-platform projects as well. If you use Kotlin for JVM, you might have already used the Java ArrayDec class, which solves the same problem. Kotlin ArrayDec is a different implementation from the Java one, which is available for Kotlin.js and Kotlin Native as well. Kotlin ArrayDec implements a mutable list interface because it can at times be convenient. The ArrayDec implementation uses a resizable array underneath. It stores the contents in a circular buffer, an array, and resizes this array only when it becomes full. When you add a new element to the head of the array, it adds it before the first element, if the space is available, and only moves the head pointer and changes the size. That's why the operation of adding new elements to the beginning works in constant time for most cases. That's much faster than when using ArrayList, which needs to move all the elements to put the first element in the first place. If you need a queue functionality in your code, a data structure that allows you to add elements to the end and retrieve elements from the beginning, use our ArrayDec implementation. It provides efficient implementation of these methods under the hood. The next topic I want to talk about is the functions for bit manipulation. They've been available for quite a while already, and most of them have become stable in this release. If you write an algorithm that requires bit manipulation, check out this functionality. In this example, we have a binary representation of the number 80. You can count all 1 bits in a binary representation of a number, or you can count leading or trailing 1 or 0 bits, or find the highest 1 bit, and so on. It's important to have these operations in the standard library. We provide efficient implementations of them, also for Kotlin native. Please share with us what other bit manipulation functions you'd like to see in the standard library. Next, I want to talk about using the standard library in multi-platform projects. When you write code shared between different platforms, you know you have a common part. This is a common code shared between JVM.js or Android and iOS. Under the hood, specific versions of the standard library are used for each platform. And there is also the kotlinx.datetime that contains many declarations and some common functionality. Platform-specific versions of the standard library only add some platform-specific functionality on top of it. Starting from Kotlin 1.4, the dependency on the standard library is added automatically by default. Before that, you had to include the standard library explicitly to every source set and specify the exact version for each target platform. But now the dependency on the standard library is included by default. It automatically includes the same version of std.lib as the version of the Kotlin Gradle plugin. But of course you can change the defaults if needed. It works not only for multi-platform projects. This dependency is included by default for a regular JVM project as well. But for multi-platform projects, it's especially convenient that you don't have to specify all these different dependencies. One of the goals with the standard library is to make it really useful for multi-platform projects. We want to make it so that the library you're using from the common code is almost the same as the one you're using for the JVM, which everyone is accustomed to. To achieve that, we are adding or moving some missing functionality there. For instance, we've moved some methods on string builder to the common library that previously were available only for the JVM. We've revised the common reflection API, and it now contains only the methods that are available for all the platforms. We added several useful methods for exception processing to the common part, like throwable print stack trace or throwable add suppressed functions. We've also introduced the common throws annotation. Kotlin doesn't have checked exceptions, but it allows you to specify them for interoperability with languages that do have checked exceptions or similar constructs. Now you can specify the exceptions that a given function can throw in the common code. Then it gets correspondingly represented at JVM for interoperability with Java or in Kotlin native for better interoperability with Swift. You can learn more details about how exactly it works for Swift in the talk about Kotlin multi-platform mobile or in the documentation. Finally, I want to go over a couple of things that are currently experimental. Note that in order to use the experimental standard library API, you need to explicitly opt in for that. In other words, you have to swear that you understand all the risks. Whenever you try to invoke an experimental function, you get a warning, and you need to add the opt-in annotation to suppress it. This mechanism was already present in Kotlin, but we've changed the annotation name. Before it was called useExperimental, and now it's called opt-in to cover more use cases. It also might be used to annotate unstable or internal APIs, so that you can use them with explicit acceptance of the risks involved. The goal of the opt-in annotation is to make users of the code agree explicitly to use certain elements of your API. As a library author, you might use it to let the community try new features as early as possible, to gather feedback and decide what works well and what requires some changes. The Kotlin standard library often uses this functionality. Let's say you're a library author and you want to introduce a new API. You can introduce it in a way so that clients of your library would need to explicitly opt in when using this new functionality. For instance, you want to introduce this foo class, but you're not yet sure it's final. You want the community to try it first and share feedback from their real-life use cases. You introduce a new annotation, Bleeding Edge API, that says that it's your new API and you annotate new classes and functions with it. You can choose whether the users of the library get warnings or errors when they call this API without opting in for it explicitly. This example deliberately uses the escape symbol of an exclamation mark in the message to emphasize that the compiler will report an error or warning with the same custom message. The message can contain the information about what changes you can expect and how stable this API is. To fix the error, the clients of the library should say that they opt in to use this bleeding edge API. They use the opt-in annotation for that. This way, they agree to modify their code if something changes, so they take the risks in order to benefit from the new functionality. A good practice is to provide a clear and automatic migration path if something changes later. In the Kotlin standard library, we try to provide automatic tools for migration to stable versions of the API. Now here is a couple of cool new things in the standard library that are available in experimental mode: collection builders and an API for time measurement. Kotlin divides all the collections into mutable and read-only collections. You choose whether you need one or the other. Sometimes, however, it might be convenient to build your object using mutable interface, but get a read-only collection or map as a result. In Kotlin 1.4, we introduced new functions to the standard library to achieve that: build list, build set, and build map. They follow the same approach that already works for strings. You can use the build string function, which operates with a string builder inside and returns an unmodifiable string as a result. Similarly, you can use build list to construct a list. It takes a lambda as an argument with an implicit receiver of the type mutable list. You can add more elements to this mutable list or parse it to another function to be modified, like in the map to call here. Build list then returns a read-only list as a result. What's more, the resulting list is effectively frozen. It throws exceptions if you explicitly cast it to mutable list and attempt to modify its content. Similar functions are available for constructing sets and maps. The second new piece of functionality I want to describe is a set of functions for measuring time. If you need to measure the duration of a specific action, you can use the new measureTime function. It returns an instance of the duration class. Duration is an inline class storing the duration in a double primitive value. So there is no overhead. In terms of underlying performance, it's the same as using primitive types. And there is no confusion about which unit this duration is expressed in, as often happens when numeric types are used for this task. You can then convert the duration to the measurement units you need. You can also explicitly use the time source API to measure time between different events. In our example, thread sleep represents an action. You mark the start moment with markNow, and then call the elapsedNow function to get the time passed from the starting point. ElapsedNow returns the duration. What's especially convenient here is that you do measurements in different places. You can start and finish time measurement in different functions. You simply pass a mark as a parameter or store it somewhere to complete it. Another new handy function is measureTimed_value. It allows you to get both the duration passed and the result of the computation. It returns a timed value, which can then be automatically destructured into two variables, in our case, a value and duration. The kotlinx-datetime library provides an API for working with dates and times. To learn more details about it, check out the Introducing Datetime talk by my colleague Ilya Gorbunov, also the author of many of the standard library changes we've discussed today. We've covered a lot of things today. New functionality in the standard library, available in Kotlin 1.4 release, naming conventions, new running fold and running reduce functions, new type array deck, operations for bit manipulation. using standard library in multi-platform projects. It includes more functionality now, and there is no need to include the dependency on it into each source set. And we've discussed some of the experimental things available for you to try: collection builders and time measurement API. If you want to read more, check out what's new on the Kotlin 1.4 documentation page. It contains a section about the standard library with more details about the functionality we've discussed today. Thank you very much for your attention, and have a nice Kotlin!
Hey Sveta!
Hi!
Hey again. Thanks for your talk. And let's not spare time and go through all the interesting questions from our community. And the first one, maybe a little bit trickier. Igor?
Yeah, let me start. I love this one. Well, Sveta, do we also get appropriate Q and DQ interfaces?
That's a trick question, and I think it better should be delegated to the Kotlin library team. So let me introduce and add to this broadcast the author of most of the changes that we were discussing today, Ilya.
Hi, everyone.
Hi, Ilya.
Hi, Ilya.
So what is the
from
question?
now on, I'm not answering the questions, but I'm just sitting there and let Ilya give you all the insights of the library development.
Okay, so the question was, will we get appropriate Q and DQ interfaces?
Yeah, we had these interfaces in plans, but we decided not to introduce them for now because their API is not very Kotlin-like. They bring some methods that are from I said legacy Java versions. So we'd like to investigate in an area of some compiler magic to rename methods of these interfaces, and after that we can bring them to the standard library and implement them in the ArrayDeck class.
Yeah, as usual, the compiler magic that just somehow hides some methods from Java interfaces, replaces them, and is like, wait for it just works, just some magic.
Well, good luck in this fight. The next question. When will Kotlin enhance its standard library so we no longer have to use all these Java collections?
Well, I don't think it would be an enhancement because if we no longer use Java collections, we won't be able to interop seamlessly with Java. So again, we use Java collections, but we hide them behind nice Kotlin interfaces like read-only lists and mutable lists. So you can work with interfaces and do not care about actual implementation.
And also there is this thing that because Kotlin reuses Java library under the hood, it's no need to write Kotlin-specific implementation. So the resulting size of the Kotlin-stdlib is quite small. So there is no need to add our own implementations. And for Android folks, like for the whole Android world, it's really important that it's so cheap to add Kotlin.
So the motto is like, use Java collections and don't think about it.
And don't worry.
Don't worry.
Be happy.
Yeah.
Okay, the next question. Why there are so many types of collections in Kotlin doing the same thing? For example, array list T, array list of, mutable list of. How are they any different? What to use? What's happening?
Oh, it's simple. Mutable list and list are interfaces, and array list is just some implementation of default one. And array list of is function which can create an array list from existing elements. So nothing complex here.
Okay. Pretty clear. And my favorite is about plans, of course. Are there any plans to build out the Kotlin-stdlib independent of Java, so we can use it in Kotlin native? Who wants to surprise our users?
Oh, actually, you can already use standard library in Kotlin native, because what would be if Kotlin without standard library? But it's...
It will be a B or a Python, as we discussed earlier.
It's not as large as Java standard library, but we can think of extending it based on your requests.
Okay, and the next question. How to ensure smooth migration from opt-in annotated method to stable APIs?
So if you're developing your unstable API and use opt-in annotation to mark these methods, when the time comes to make them stable, you just remove requires opt-in from that experimental annotation and deprecate it. And all your API becomes stable, and the annotation usages become deprecated, so user can remove it from their code.
Igor, did you understand?
Yes. Thank you. I don't have a very clever face, so people always think that I don't understand something.
Ilya, Sveta, thanks again. Sveta, thanks again for your talk. Ilya, thanks for answering our questions. And as I know, you maybe have some important stuff.
Guys, yeah, I have some important stuff to do, so I'll better be going now.
Okay.
Bye.
So we don't want to. Yeah. Okay, Sveta. See you later. See you in our Q&A part.
Thanks for your talk, Sveta.
Bye-bye.
It was really great. Okay, so let's continue. Once again, thanks for answering us about animals, but it's time for a new shiny idea. As far as you know, Kotlin is already presented on Twitter, Facebook, Reddit, and many other social networks. But you know, there is still no Kotlin account on TikTok. So the question is, give us some funny and crazy ideas for Kotlin TikTok videos that you would like me, Kate, or some other member of our team make. So we are waiting for your ideas.
I'm a little bit afraid and excited about these ideas, and that I think after that we need to to record and to create all the stuff based on your imagination. So, but I'm ready and I'm waiting for it. While you're thinking, Igor, I have a question for you, and I think it will be a really interesting experiment. So,
okay.
Yeah, so are you ready to pass the test for your product management skills here online at Kotlin online event?
Wow, so stressful, much danger, but yes, I'm okay with it.
Yeah, you are a brave one, so I love it. As a product manager, of course, you need to know what are the most popular requests, feature requests from our users. And I think this question must be very easy for you. So right now I will write down the answer on my sheet, and I want to ask you a question. I will count down from 3 to 1, and you need to answer. Are you ready?
Mm-hmm. Yes.
Yeah, okay. So, what is the most awaited feature from our users in whole Kotlin? Language, ecosystem, library, tooling, whole Kotlin world. The most awaited feature. 3, 2, 1.
Datetime!
Oh my god, sorry Igor, I'm so sorry. No, you are the best product manager. Of course, it was a joke, and you are right. This was an answer. So now I want to introduce Ilya Gorbunov. Yes, that was the serious stuff, this important stuff, and the reason why he has gone away. So Ilya joined Kotlin team in 2015 and roughly a year before Kotlin 1.0 release. Well, a long way, yeah. He has been working mainly on the standard library since then. And some say that in order to write in Kotlin, you have to study Java first. But interesting fact, he came to developing Kotlin without knowing much Java, straight from C#. So, no more words. And introducing datetime. Let's enjoy the talk.
Hi everyone, my name is Ilya and today I will talk about our new shiny kotlinx-datetime library. But before we talk about the library itself, let's take a quick look at the state of the Kotlin ecosystem regarding working with dates and time. If you target a single platform, you have Platform API at your disposal. If you're lucky enough to target JVM 8, you can use pretty decent Java Time API. If you're not so lucky and still have to work with Java 6 or 7, you have only legacy Java util-date in the platform, but you can resort to third-party libraries. All these single-platform APIs can more or less suit your needs, but if you're developing a multi-platform application, it quickly becomes tedious to work with these expects, actuals, to think about each platform's peculiarities. So there is a clear request to develop something multi-platform that can hide all these platform differences under the cover and provide a unified API. And while we were designing our kotlinx-datetime library, not so in a hurry, I must admit, a couple of community multi-platform datetime libraries emerged during that period. To name a few: Clock, Fluid Time, Island Time. These are pretty different libraries. They support different sets of Kotlin platforms. They have different philosophy behind them. We're not saying that the release of kotlinx-datetime puts the end to all these libraries, because we pursue different design goals. So there's still much room for different ideas in this area. What is kotlinx-datetime library? It's a multi-platform library that supports all major Kotlin platforms. Kotlin JVM, though it requires JVM 8 or higher because we base our implementation on the Java Time API. Kotlin JS, and a variety of targets for Kotlin native. The design principles behind our library are following. We use immutable types to represent temporal values. The historical perspective shows us that immutability is not a good property for value types, such as dates. Then we strive to provide a minimal API that solves most practical use cases. We'd like to avoid complex class hierarchies in order not to overload our users with a lot of choice, increasing risk of this choice being incorrect. We design the API in such a way that incorrect or unsupported operations are prevented at compile time rather than failing at runtime. Let's take a closer look at what we are trying to avoid. In this snippet, implemented with Java Time, we have the date of today and we're trying to find the date of tomorrow. One can find that local date type has the plus function that accepts a temporal amount value. We know that the duration type implements temporal amount interface, so we can construct such an innocent-looking expression: date plus duration of days 1, and expect it to give us the date of tomorrow. But if we run it, we'll get something like this: an unsupported temporal type exception with not so clear exception message, unsupported unit seconds. We want to avoid a situation like this, and thus the principle: if the operation is allowed by the API, it should work for reasonable arguments. And last principle is that libraries should be foundational, so that when it becomes mature enough, third-party libraries could provide extensions for it that cover more advanced use cases. Before we meet types that are used to represent temporals, let's talk a bit about flavors of time. First, there's physical time. It can be imagined as a timeline, where one moment follows another moment, and we can represent a point on that timeline using just a number of unit intervals in some designated moment of time called epoch moment. In our library, we have the instant type to represent that integer number of nanoseconds in epoch. We can obtain the instant corresponding to the current moment of time using the system clock. We can construct it from the given number of units since epoch,
be it milliseconds or a pair of seconds with nanoseconds, and we can parse an instant from its ISO string representation, something like this. Then there is civil time. It's how people conventionally track time in their locality. For that task, it's much more convenient to use a wall calendar and a wall clock rather than the number of nanoseconds since epoch. Readings of the wall calendar, year, month, and day can be represented with the local date type, and combined with the readings of the wall clock, hour, minute, second, nanoseconds, they form local date time type. We have seen that time can be tracked in two ways, and clearly there should be some way to go from one time flavor to another, right? Suppose you have an instant and want to get a corresponding local date time representation with convenient date and time components. For that, first we use rules of the Gregorian calendar. They define how many days are per particular year, month, how many hours are in a day, and so on. Using these rules, we can calculate the date and time components, but this will be the components of the UTC time. However, in different parts of the world, each area has its own time that is offset from the UTC time by some number of seconds. A time zone object gives us that offset for a particular location and time. Now you get a time zone, for example, the current system default one, and pass it to instant local date time function, getting local date time as a result. The opposite situation is when you have a local date time, for example, constructed from components, and you want to get the corresponding instant of physical time. For that, you also need to know the time zone, pass it to local date time to instant function, and get the instant as a result. In this example, if you convert instant back to local date time, you get the date and time components same as the original ones. So far it looks easy, right? But this conversion has some intricacies related to the daylight saving time. For example, in Spring we have forward clock shift, when the time zone changes its offset from the standard one to the offset 1 hour later. Locally, it can be experienced as if the clock just skips 1 hour at a particular time. We can see that there is time on the local clock which doesn't correspond to any instant of physical time at all. And in case one wants to convert a local date time that lies in that skipped hour with a to-instant function, we need to devise some strategy how to deal with this situation. By default, in this situation, we convert it as if no time shift happened. So we use the offset of the time zone before the shift. If you convert the resulting instant back to local date time, you can see that the time components are different from the original local date time because of this correction strategy. Then in autumn, we have another situation when the time zone also changes from its summer value back to its standard value. Locally, it can be seen if clock jumps 1 hour back at a particular time and goes that hour once again. In that hour, one local time can correspond to two different physical instants. And again, we need some strategy to convert such local date time to an instant. In this case, we choose the earlier of the two possible instants. You can notice that if you add 1 hour to that instant, you get another instant not equal to that with the same local date time components. The important takeaway here is that the conversion from local date time to an instant is not always unambiguous, and the conversion in one direction and in backwards is not always a round trip. Now, when we've met these types to represent temporals, we can ask a question: when is more appropriate to use each of them? First, imagine a situation when you want to log a message and you want to prepend a timestamp when the message was logged before it. How do you do it? You get the current system clock instant and render its string representation before the message. In the result, you get something like this. It's the ISO representation of an instant, and that in the end designates UTC time plus 0 offset. That's a reliable way to represent an instant because it can be reconstructed back from the string unambiguously. But it may be not so convenient if you run your service just in one region, in a single time zone, so it may be more convenient to you to see timestamps in the log local to your time zone. In that case, you can obtain a local time zone, for example, the system default one, and use it to convert your instant to the local date time representation and output that to the log.
But from that representation, you can't reliably reconstruct what the moment of physical time it was without knowing the time zone or the offset. So it may be still a good idea to store the offset beside. This allows you to pass this log later and reconstruct the stored timestamp exactly. Then instant can be used to represent a moment in the past, for example, a modification timestamp. Suppose that you're implementing an HTTP server that services client HTTP requests. A client makes a request for a resource. When it already has that resource in its local cache, it doesn't want to download that resource again if it has not changed since the last time. So in order to do that, the client passes an if modified since HTTP header with the timestamp of the last resource modification known to the client. The server then should determine whether or not the resource was modified since that timestamp. To do that, it obtains the value of that header as an instant and then compares it to the resource modification timestamp known to the server. In case if that timestamp is earlier than or the same as the client's one, the server can respond with not modified HTTP status code without sending the resource content. And otherwise, it has to resend the resource content entirely. What about future moments? Instants can be used to represent the future. Consider a scenario when you're implementing now an HTTP client and caching a response from a server. The server puts such cache control header into the response to indicate how long this response can be cached. Max age is the maximum age over cached resource expressed in seconds, and this amount of seconds roughly equals a year. The client calculates the cache expiration deadline by taking the current moment and adding the number of seconds from max age converted to a duration to it. It stores it together with the cached response content. Later, when the resource is needed, this deadline can be used to determine whether the cached content is still fresh or already stale. If the current moment is beyond the deadline, it means that the resource is stale and should be refreshed. Otherwise, the cached content can still be used. What we have seen in these two examples with future instance and past instance is that they do not require time zone for calculations. Such code works in any time zone as long as you use instants, which are basically fixed in UTC plus 0, so it might be tempting to give an advice to define such a rule of thumb. Just use instants everywhere and only convert them to local datetime for formatting, presenting the value to a user, and avoid storing moments as data. But would it be a good idea to follow such advice? Let's consider this situation. You're scheduling a meeting in a distant future, for instance, 5 years from now, year 2025, you pick some local date and time components, for example 1 p.m., and construct local date time from them. Now you use the user time zone, Europe, Berlin, in this example to convert that local date time to an instant and store it together with the time zone to some database. And after some time, you read the stored instant and time zone back and get a local date time from them to show in the calendar or to display a notification. But imagine what would happen if Europe abolished daylight saving time. I heard some rumors about it. It would result in the same time zone having a different offset in future for the same instant. And if you convert a stored instant to local datetime with that different offset, you get different datetime components. And in the result, the meeting will move to a different time. An hour later, maybe an hour earlier, not a very good situation. So it's important to think about what the source truth is in your application and preserve it when persisting data. In this situation, it's clear that when you schedule something to local datetime, you want to have that local datetime preserved. And it's more appropriate to store a pair of local datetime and time zone instead of an instant and time zone. An attentive listener might notice, if we need to store a pair of local datetime and time zone, why don't we provide something like zoned or offset datetime? What are offset and zoned datetime types? Offset datetime is a local datetime combined with an exit offset from UTC, and zone datetime is a local datetime plus time zone, but it also contains an exit offset from UTC in order to determine the corresponding instant unambiguously. These types can be convenient in datetime calculations because you have everything at hand, all components that are needed to perform an operation.
But these types have some drawbacks. First, problematic compressions. Two values corresponding to the same instant, but with different offsets, are clearly not equal, but it might be unclear which one is greater than the other. Second, in an operation that takes several temporal values, but only one time zone or offset, it's unclear from which value to take that time zone, because each value can have its own one. And finally, if time zone rules change, a stored offset value in zone datetime may become contradictory to that zoned time rules and requires correction. That correction can be done in different ways. Thus, we are avoiding introducing these types until we have a strong use case, which would be impossible without them. Now, when we know when to use each type, let's see what useful operations we can do with these types. Here we have a build running on a continuous integration server. It started at some particular instant of time and lasts for some duration, and we want to find this duration to show it in the UI. We can represent the moment build started as an instant, get the current instant, and just subtract one from another, and get a duration between them in the result. The duration is an experimental type. We have it in the standard library since 1.3.50 to represent a duration amount. It's actually unitless, so it doesn't have any particular duration unit tied to it, but it can be expressed as a number in any given duration unit, for example, in seconds, in minutes, in hours, or as a combination of them, and that result can be shown in the UI. A different situation is when you're making a chat application and you want to know how much time has passed since the last reply, and if that time is large enough, you want to show it as some number of days or in month ago. Probably you can find a duration between the last reply moment and the current moment, and just convert it somehow to days or month. There are several problems with this approach. First, months and years can have different lengths in days, so we can't just take any duration and convert it to a number of years or months. We need to know how long the particular months or years were between these two instances. And for that, we need to know what local date and time components this instance have. The second problem is that a day is not always 24 hours, as we have seen in the daylight saving time examples. It can have less hours when one is skipped, it can have more hours when one is counted twice. So the operation we want to perform with this instance needs to account for these daylight saving time effects between them. And to do that, we'll take the first part of this advice by Stephen Colburn and introduce the function until, which takes a time zone, converts this instance to local date times and in that time zone and calculates the duration between them expressed in a specified datetime unit. There are plenty of predefined datetime units from centuries to nanoseconds, but for these three units, we have handy shortcuts: days until, months until, and years until. Now imagine you want to show a countdown timer that updates every second and show how much time remains to some future event or has passed since some past event, for example, since the moment Kotlin 1.0 was released. And that time should be displayed as a mix of different units. We can represent the moment of that event as an instant. I did some historical research and found that Kotlin was released on the 15th February 2016 at 6 minutes past 13 UTC. So how can you do it? Again, you have the current instant, the instant of the event, and now you use period until function. Instead of an integer number, it returns a datetime period structure having the length of the interval between the instance expressed as a mix of normalized components: years, months, days, and so on up to nanoseconds. Using these components, we can get the desired string result. But what if you don't know the precise moment of an event and only know its date? Not a problem, you can use a similar period until function to find a period between local dates. Return type, date period, is a subtype of datetime period. It has only date-based components, and all time-based components are fixed to zeros. Now I'd like to show you how Kotlin language features help us to design aspects of the datetime API. For example, when you do a lot of conversions from an instant to local datetime and back, you may notice that constant passing time zone parameter becomes repetitive. What can we do about it in Kotlin? We can extract that time zone to a context as an implicit receiver with our scope function with, and now call to instant local datetime without passing that time zone explicitly because it's taken from the context. How does this magic work? It's possible thanks to having to local datetime and to instant extensions defined as members inside time zone class, so-called member extensions. This is pretty sleek, but unfortunately, it's not so extensible. All such extensions have to be declared as time zone members, and because of that, we want to stop on these two functions declared in such a way for now. So for other operations that require time zone, you still have to pass it explicitly. Then datetime unit type. It specifies in which unit we get a result of until function operation expressed, or in which unit the number provided to plus function is expressed when we are adding a number of units to an instant or a local date. There are plenty of datetime units predefined: years, months, days, time-based units such as minute, hour, and so on, more elaborate units such as a week, which is 7 days, or a quarter, which is 3 months. One can think that it's just an enum with a fixed set of values, but actually these predefined units are just constant properties in the datetime unit companion object. If we want, we can declare our own datetime unit as a multiple of an existing one. For example, if you need to express a duration between two instances in 4-week intervals, you can multiply the week time unit by 4 and use the resulting time unit in the until function. This is possible due to times operator being declared in datetime unit, and it produces another datetime unit which is a multiple of that. Another aspect of datetime unit class is that its design helps to prevent problematic operations. Remember that case with adding duration to a local date in Java time? That results in an exception only at runtime. In kotlinx-datetime, you just can't add 1 minute to a date, either using the plus operator or the plus function. The first is impossible because there's no such operator overload. It takes local date time and a duration. The second is prohibited because local date plus function takes not any datetime unit, but only datetime units that are date-based. Datetime unit is a sealed class that splits to date-based units such as day, month, year, and time-based ones. And minute unit is clearly not date-based, so it can be used here. Okay, let's take a moment to recap what we know about the library so far. So in the library, we have types to represent temporal values. We have date and time arithmetic operations such as duration, until, plus, and minus, and some helper types that are used as parameters or return values in these operations. But what to do if you have a use case which is impossible to achieve so far with the provided set of API? First, it's important to report it to the library issue tracker on GitHub. Then you still may have luck with the platform API. But to use it, you don't have to rewrite everything to the platform types. In JVM platform, we provide the conversion functions from our kotlinx-datetime types to Java time types. You can convert a value, do the desired operation in Java time domain, and convert the result back to kotlinx-datetime types. For example, if you want to format an instant in such a format that we have seen in HTTP requests and responses, you can use this RFC 1123 datetime format instance of the datetime formatter class from Java time. But it requires Java time zone datetime on input. So first you convert kotlinx-datetime instant to Java time instant, then convert it to zone datetime with add zone function, then pass it to that datetime format. In Apple platforms, we also have the similar converters to platform foundation types. For example, you can convert an instant to NSDate or local date to NSDate components in order to format them. How to try this library in your project? In a multi-platform project, you can declare just one dependency in the common main source set, and Gradle will take care of finding a relevant variant of the library for each platform you have in your project. If you want to know the details of how this magic works, I recommend you listen to the talk by Dmitry Savinov the next day. And in a single platform project, you can declare the same exact dependency in the dependencies block. We have released kotlinx-datetime library 0.1 version. Maybe it will be a later version at the moment of the talk, but it's definitely not a final version and not the end of development. I'd like to share what we have in the near-term roadmap. First, we want to provide an integration with kotlinx-serialization library. In a distributed multi-platform application, it's a fairly common task to serialize data in one part of the platform system and then deserialize it in another part. So we'd like to provide some ready-made serializers out of the box. Then we want to support such a certainly important feature as formatting and parsing. At first, it will be without internationalization, so it will support just English names for month and weekdays. We also want to support ranges and progressions of temporal values so that you can iterate them. And finally, we want to provide a way to embed a time zone database. Why is it important? We rely on platform API for working with time zones. And due to that, it may be absolutely unpredictable which version of time zone database is going to be used in the platform where your application runs. So you can get different results of operations involving a time zone from what you have expected. This could be mitigated by bringing a particular version of time zone database embedded with your application. So please share your feedback, because at this point, it can considerably affect the direction of our development. You can file requests for the missing API in the GitHub issue tracker. You can use the Kotlin forum for discussions, and in the Kotlin Slack, we have dedicated kotlinx-datetime channel, and we'll be glad to see you there. So, thanks for watching, and have a good time with Kotlin.
Hey Ilya, hey again. How do you feel?
Yeah, I've managed to do it.
Yeah.
What a speed,
It's
what a
good.
speed.
Yeah. So let's continue our discussion, and now about datetime. And I think this is a real popular question. Android lacks a lot of datetime functionality. Kotlin datetime will be a great plus. Will it be interoperable?
I think you could use this library in Android pretty easily. But if you target older Android versions, you have to enable that feature called library desugaring. It's available in Android Studio, if I remember correctly, 4.0.
Okay, thank you.
Okay, is the time zone of function parameter an open-ended string? Meaning it doesn't need any specific format for, I don't know, city name?
No, the format of time zone name is strict. It has to be in the time zone database in your system. So you can, it's usually it's region/city.
Okay, got it.
Very simple and straight. Does it provide format to string and parse?
Currently, we support only ISO 8601 format for formatting and parsing, but we definitely have plans to bring common formatting facility in this library. Meanwhile, you can use platform ways to format string using the interop I showed in the talk.
And maybe do you have any specific plans in which releases this format will be provided?
I think it's 1 or 2 maybe releases from this from now.
Okay, waiting for it. I've recorded. We're all recorded, and now waiting for it.
Okay, and the next question is about extensibility. Will datetime library support Iranian calendar, or maybe some way to extend current calendar rules?
Datetime library, in datetime library, we support only the ISO calendar, it's Gregorian calendar, but we think that other calendars can be implemented as some kind of third-party extensions. So just converting ISO date into date in other calendar systems.
Okay, thank you.
And will all this be back supported with old Android API levels?
So as I said earlier, in older versions of Android SDK, you have to enable library detriggering.
Okay, and a tricky question. Do you support leap seconds as the 61st second of a minute?
In short, we pretend as if leap seconds didn't exist. But in long, we use time scale where 1 second is not equal to I second. It may be a bit longer or a bit shorter. So there exists conversion using which you can convert from this time scale we use to the time scale that includes sleep seconds.
Okay. So, thanks. I think that was the last question. And
we
thanks,
will
Ilya.
definitely meet again,
Yeah.
you, Ilya. I'm happy to say this.
I think we'll meet again in 5 minutes. And now me and Kate should take some time to wrap up answers for the question about TikTok, which we asked a bit earlier.
Yeah, and thanks again for your ideas. We already have a backlog of all this crazy stuff.
We
and,
already downloaded TikTok.
Yeah, we already created an account.
Me no, only Kate.
It was a secret. Please delete it from the stream. Okay, let's go. Igor, please share the first one.
Okay. Type on many keyboards at once to express the idea of fast development, like something. Wow, wow, wow.
Not bad, not bad. Another one. Tip of the day. We have this hashtag in our official Kotlin Twitter account, showing something cool you can do with Kotlin. Nice, and you can use screencast there. I love it.
Okay, the next idea is also a pretty serious one. So a good idea would be videos or snippets of showing new Kotlin upcoming feature teasers or something like it. So like announcements.
Yeah, feature teasers. I like that. And we can use this music for some film trailers, which is so exciting. Yeah, and like something very important is happening. Yeah. And a few funny, but it's also important to have some time to rest from all our serious and important tasks. And this is a quote. I want Igor and Kate singing. Sorry for that. Pops.
No. I've opened this video. I listened to this song, and it sounds like me pops ju. I like this one. Okay, and yeah.
No. Just can't continue thinking about it.
Yeah, and the last one is to show how Kotlin programmers celebrate finishing a new feature. Yeah, I think we especially needed this when we finally finished 1.4 release, because yeah, that would require very many TikToks, I think. Whew. Okay, so thanks everyone for those ideas. We put them on our backlog, and yeah, and now we are ready to move to the final part of today. And well, today we discussed so much new stuff in Kotlin libraries. And if you still haven't tried it out yourself, you should definitely do it and leave us your feedback either in UTag or in some other channel. And now let's proceed to the big Q&A session with all Thursday speakers. And don't forget to submit your questions to YouTube chat.
Second day.
Yeah.
But for today we also will have big Q&A part. Every day we will have this big Q&A part.
Yeah, sorry. We are waiting for your questions right now in the YouTube chat, and we are waiting for your questions for the next day, where you should leave your email so that if you win the best question award, we will give you a Kotlin themed mug, which is pretty great. Yeah. So now let's invite all today's speakers Okay, let's do it.
Of course. Hey again, Ilya.
Hey Sveta
Hey, Seva.
and
Hey,
Leonid.
Leonid.
Hi
And
there.
a special guest for the second day is Roman.
Ooh, hi everyone.
Hello.
We've got pretty work to do, so let's go through all these exciting questions. And I think the first one goes to Ilya. And Ilya, what is the difference between Kotlin standard library and the libraries in Kotlinx?
We include only core functionalities in the Kotlin standard libraries, and some other domain specific goes to Kotlinx. That's a simple distinction.
Okay, pretty clear.
Okay, the next question is also for you, Ilya. Well, what is the equivalent for multiple try resources in one try?
I think you can use the function named use, and you can use it multiple times, just nest it one in other.
Okay.
And it's great that Roman could join us today because the next question, I think, goes to Roman. So, given that max-min will be reintroduced in later versions, does that mean that you will make non-empty collections?
I wonder what does it mean, how it has, what it has to do with non-empty collections. Now, we actually don't have any plans to introduce special times for non-empty collections, since in practice, bugs relating to collection emptinesses occur so rarely that, but if you introduce non-empty collections, that would like complicate the temp system for everybody, even for most of the people who don't care and don't have problem tracking in, don't have problem figuring out in their functions whether collections are empty or not. So far we don't have any evidence that emptiness or non-emptiness of collections causing any real production issues at scale to make it worth fixing.
Okay, I have nothing to add, of course, as expected.
Okay, which is the question for Ilya? Which is the roadmap for unsigned types? Are they still experimental?
Yeah, unsigned types are currently experimental just because they are declared as inline types, and inline types are themselves experimental in Kotlin. But we are committed to having unsigned types in future. So even if we somehow redesign or inline classes feature or even reject it, the unsigned types will remain. So we committed to support it.
And the next one is, I think, quite philosophical again, and again goes to Roma. And Roma, how would you design arrays from scratch? I'm not sure if we will fit a full answer in our Q&A part, but let's try to make it compact.
No, I mean, this is a tough question because I don't think they're really a good way to design arrays on JVM, especially if you design a language that is, I mean, you can ditch the goal of nice interop with Java, and then you can do whatever you want, and some language did it, and it works great for them, but not for Java interop. Or if you're really looking for nice interop with Java, then you don't have much choice. So, I mean, it's not that there are some mistakes in arrays design that could have been fixed easily. I mean, at least there are no easy fixes. I mean, we're looking at some ideas what we could improve in the future, but that would require a lot of work in terms of the compiler to bring any significant improvements to user experience. And not that it really matters much. I mean, arrays are really low-level things. You would use them rarely, only when designing other high-level data structure. Your regular business code that you write like 99% of the time, there's no reason to ever use collections. You just use, lists, to use arrays, sorry. You just use list out the collections, and they reach, they give you lots of features. So, I mean, there's no much reason to worry about arrays design.
Okay, thank you.
And now let's talk a bit about collection builders. Well, the question is simple. What's their benefit? I think, Ilya, you could probably answer it.
Yes, since Kotlin 1.0, we have build string. It can be seen as a builder for immutable string type. Same, we added builders for collections, and they have several benefits. They allow to populate a collection and return it as immutable, as read-only.
Got it?
Yeah. Anyone want to add to it?
Yeah, sure. Basically, it's a DSL, and DSL, it helps to read code better. You're able to reflect your intent better, and code is usually more read than is written. So it's just a good way to express your intent.
Okay, so our favorite kind of questions, because we can turn on our imagination. So what is your plans about supporting non-blocking I/O operations with disks? I think Roma or Seva could answer this.
Yeah, I can answer that.
Okay.
Sure. So basically, now you're able to use it with coroutines. You just grab any access to I/O or disk, or any disk with dispatches.io, and that's it. The more advanced usage just depends on operating system implementations, which are far from complete right now. For example, Linux is planning to add it in its latest versions. It's called IO Ring, I suppose. And as soon as it will be ready to use in more or less mainstream distributions, and in Java, we are going to introduce it probably in a separate library, such as kotlinx.io or kotlinx file system. It's an open question yet. It's an open question.
Okay, we already discussed the distinction between Kotlin standard library and the Kotlin X libraries. So let's talk about it a bit more. And how do our team decide what features go to standard library and what feature goes to extended libraries? Maybe Seva?
Okay, so the general answer is it depends, obviously. Because, as Ilya already mentioned yesterday, standard library is small, self-contained, and contains very basics for the language. And it evolves slowly. It evolves along with the language. It has a fixed release cadence. And some specific domains, they require a lot of API. For example, a file system or dates. And we want to release them fast. We want to gather the feedback. We want to evolve them. We want other users to have an alternatives, for example, and then it goes to kotlinx libraries.
Great.
Okay. Both questions and answers are very interesting, and we can have really comprehensive discussion, but I think we should make a small break, and the next question will definitely help us to do this. So, folks, are you ready? Very important question. Is Leonid Startsev fond of Python? Sorry.
Well, definitely of
Answer Tolstopyatov.
Not the language.
Okay. The next one is a bit holy war. I think it goes to Roma. Well, why have you created lots of functions like int array of, long array of, while you could just make simple collection literals?
Actually, collection literals, we're looking at creating collection literals. That's indeed one topic we're looking at language design. But it's, the confines of this Q&A session are too short to elaborate on what's complicated about just simply adding collection literals. Will definitely deserve a talk at some future event to just about collection literals, to explain what are the challenges of them, what complicated issues they raise, and how we're thinking we might be able to get away with them or might not be. That's the really big topic, unfortunately.
Mm-hmm.
And
okay,
I have one question. I think it goes for a majority of you as an authors of multi-platform libraries. So does the requirement to make your library multi-platform and support multiple targets goes with overheads, and do you have really many obstacles, or it just looks like the regular process of creation of any simple pure Kotlin library?
We had a lot of obstacles in the beginning, but now it's becoming better and better with each release. So now it's not a big deal to create a multi-platform library from scratch, for example. Even IDEA has a wizard, project wizard for it. You can create it just by punching some buttons.
Team were main battle testers, and now it's a smooth process.
The main obstacle for creating multi-platform libraries, common libraries which don't have any platform-specific code, is distributing. So for now, you have to compile and publish it for every platform. But otherwise, it's simple. Yeah.
Okay, and we have some more questions about coroutines, which I missed, I think, somehow. So, Seva, prepare to answer them. Well, are coroutines mature for JVM backend server?
Yes, of course. For example, even Spring endorses them and have its support in latest releases. Coroutines were stable for a few years, I think, and they're ready to be used everywhere. So go ahead and try it.
Metaphors is one of the best way to understand some new concepts. So the question is law the same reactive object that was introduced in Java 9?
No, it's not. In Java 9, it was a specific reactive stream implementation was introduced, which is a collective effort of Eric's Java team, Project Reactor team, and other reactive libraries. And it's rather similar to Eric's Java than to the flow. And again, it's not Kotlin specific. It doesn't know anything about suspension, for example.
Well, I've read a lot about coroutines. Well, not me, but Werner Thumann. He read a lot about coroutines. And now, what is a good idea to gain practical experience? I think can be an open
question. Just do it.
Yeah, go ahead and write some simple application. For example, I used to write a small HTTP client that download JSON from a web server to learn a new language. Just as simple as that.
And share your experience with us.
When someone is looking for a pet project, I often suggest making some kind of Telegram bot or other chat bot, because you always have some ideas for chatbots.
Yeah, it's also a good example. It can be done in one evening, let's say, and it's still a great source of knowledge and practical experience.
And we have one question, not Kotlin related, but I think it's a good one to finish our discussion. So I think it goes to Sveta, but how is the experience of holding such an event online instead of how you usually do it? How do you feel about it?
Yeah, probably you've noticed that there is no KotlinConf this year for some reasons, world reasons. So we had to do it online, and we hope you enjoy it. And we are now in the middle of our event because it's 4 days, and we listen and read to your feedback. So share with us how it's going, whether we need something to improve. How do you like pre-recorded talks and these Q&A sessions afterwards? And if we can do something different in the rest of the days, we'll try to do this. So from organization standpoint, it was interesting experience for us because it was all new and fresh, and we haven't done a similar thing before.
True.
And what about speakers' experience? Maybe Sveta or Roma or someone else? How does it differ?
We convinced, or as you see, we convinced all this library team to do talks about kotlinx libraries, and I think that's a good achievement from our side. So thank you all, folks, and I hope you all will be common speakers, if not before, frequent speakers in our future, hopefully KotlinConf releases.
Okay. But it wasn't easy to record. Yeah, it's pretty unusual experience. to give a talk with an empty hall.
But it's
But
interesting
now-
later that you can be at the same time speaker and listener.
And answer all the questions live. And now I suggest you to go through all the comments during the live stream, and you can feel this lost energy that you usually should have if we're speaking about regular format. So yeah, I will definitely do it after after we finish our stream. Well, so I think we're ready to finish, and folks, again, thank you very much. Thank you very much for this day, for this great content and hot and interesting discussions. It was very, very exciting, and I will miss you all and our listeners, our attendees. Thank you. And tomorrow definitely gonna be a hot day, and because we will speak about Android and, wait for it, KMM. Kotlin multi-platform mobile. Yeah, you need to remember. Finally. And while you're waiting for it, don't forget to complete all the quizzes and prepare questions for tomorrow.
Because our Kotlin-themed marks wait for you.
Yeah.
Okay. So I think that's all.
Yeah,
Yes?
and if you enjoyed our crazy Russian accent and our jokes, me and Igor are hosted podcast in Russia about IT, and we will definitely send a link. Yeah, I did it. Yeah, so
Yeah, and
now
we
can finish.
even have one English-speaking episode with Björn Startsev. You can start with it and then switch to Russian.
Yeah. Thank you again. It was a great day.
Thank you for hosting this day. Thank you.
Thanks everyone.
Thank you.
Bye-bye.
Thanks a lot.
Bye-bye.
Bye.